is a brief history of the Corliss engine and how the Corliss engine works. What you're looking at here is a scaled down model of a Corliss engine from 1904. A full-size Corliss engine of this type would make about 150 horsepower and run at about 100 RPMs. This is scaled down version from a factory that was running about 15 minutes away from our shop in Sturtevant, Wisconsin. Our founder made this in the 1930s, and it's just a super neat little replica. And I just wanted to share some more details about what it meant to our community as well. Going back to 1901, this engine was running in a little town, and they named the town after it because it was so important. The factory it was in. They named the whole town Corliss after this. Shortly after that, the Brown Corliss Engine Company went out of business. They filed bankruptcy. And then in 1923, the B.F. Sturtevant Company from Boston, Massachusetts bought the whole factory and the whole company, and then they renamed the town Sturtevant, Wisconsin. So to this day, it's still 15 minutes away from us, and this is just a neat little part of our local history. And this engine means a lot to us internally at our company because our founder built this model. It's just special to us. So I wanted to get into how it works. So I'm going to turn it on here so we can check this out. So it won't start when you're in top dead center because it's only a single cylinder. So I'm just going to give it a little start here. And you can see how it's working. So in the day, of course, this would have been running off of steam. We're just going to run it off of air pressure I get from the shop here. It's going to come through, and we're going to regulate it down to a manageable pressure. So it's going to come through this pipe here, and then it's going to go through the main throttle valve. This throttle valve doesn't quite work like what it works like in your car. This is just wide open unless you want to stop the engine. Of course, back in the day, they would have closed this off, and this would have stopped the steam coming in. So from here, it's going to go down, and then it's going to be on the whole top of this engine, and it's going to be on the back side of the intake valves. And so as soon as an intake valve opens up, it's going to push the cylinder and apply the power. And of course, once the cylinder gets to the other side, it'll flip over, it'll exhaust down here on that same side, and then open up the intake valve. And so you get power going back both ways. It's a double acting cylinder. So you can see this wrist pin that we talked about. This mechanism here is a bunch of what the patent covers as far as how this is working. Of course, there are other steam engines of the day, but what really made Corliss special was how efficient the Corliss engine was because of this wrist pin design and this intake valve design. Now this really blew my mind once I understood this, but this is a variable valve intake valve design. If you know anything about cars, you know that variable valves didn't come on the scene in production cars until about the 1980s. So here we're talking about a design from the 1840s that had variable intake valves, which, I mean, it took over 100 plus years to make that into cars that we were driving around. So that was just kind of amazing to me. So as we continue to go through this though, the intake valves are going to let the steam in. The valve does its work. These are the two exhaust valves on the bottom. That's of course letting the steam come out, or the compressed air in our situation. Up here we have the centrifugal governor. So there's two weights, and as the engine speeds up or slows down, those weights move up and down, and then that lever here is going to control how the intake valves are opening. So that is how it's going to control how much steam is coming in and ultimately what RPM it's running at. As the engine's running, of course, it's turning this big flywheel. That's going to keep the momentum going so it can make it past top dead center. And then if this was in like a factory, you'd have a big belt, and it might run all the way up to the ceiling, and then that belt might run to other pieces of equipment in the factory. And that would be doing the work of whatever the machines needed to do in the factory. So super cool engine design from the 1840s, very impressive. It's cool that this replica still works. It's particularly important to us for a couple reasons, and I just wanted to call out some observations that I made about this. My favorite thing here is, here there's a little plaque that you can see, and it says Fred Knapp, Racine, Wisconsin. So that was our founder of our company. He was so impressed by this that he made a little replica of it. Then the intake valve timing, like I already said, to think that over 100 years before we ever saw that in cars, it was already working in a steam engine, all by mechanical means. It's pretty neat. Of course, there's just a beautiful design. It's fun to watch, and we're going to get into some more experiments on how we can control the speed on the outside with some of our AirLogic products. But it's fun just to watch this thing work. And the very last thing, which is just kind of fun, is there are lubrication points all over on this thing. And it's just amazing to think that it was probably somebody's job just to go around and lubricate every single point that moves. You can see all these little cups that sit on top of every joint that's moving. Each one needed a little bit of lubrication. So much so that there's a little lubricating oiler sitting there, just showing that it was that important to keep this machine running that you needed to lubricate it. I really enjoyed looking at this thing. I really enjoyed doing some research about it. I hope you guys enjoyed it.